Hi, linear algebra students. In this section, planes and hyperplane, we'll do an example, which is to find a point of intersection between a plane and a line. Okay, so point of intersection. So the thinking process is to use the fact that the point will be both part of the plane and part of the line. We will write that soon. So between a plane, so a plane that I will color code in this example in red, and a line that in this example I will color code in blue. Okay, so this is the plane, this is the line. Okay, and it might just have, most of the time it will have only one point of intersection. Sometimes it's gonna have zero. This will happen when the line is parallel to the plane. And sometimes it will have infinitely many, which means that the line will be contained in the plane. So that being said, let's solve the example. The idea is to write something like this. So x will be in the plane if this equation is true. Okay, so nothing amazing here. Okay, so actually let's write x1 plus 2x2 minus x3 is equal to 3. So we will write x as being x1, x2, x3. Okay, let's actually write this here. X, we will just label this as x1, x2, x3, just so that that's it. Like our notation is matching. Now, x is in the line if. And now you have to read this vector equation carefully. So if x1, x2, x3, okay, is equal to, and now what we're going to do is we're going to pair these together. We're going to be like 1 plus t. So in other words, okay, here I'm going to color code a little bit more just for you to see what happens. What we do is we pair up the components together, right? So first component, second component, third component. So in other words, we have 1 plus t as the first component. The second component, we have negative 5 plus 2t. And the third component, we have negative 3 plus 2t. Okay? So x will be part of the line if x1. So actually, let's now transfer this into three equations in x1, x2, and x3. So if x1 is 1 plus t, x2 is negative 5 plus 2t plus 2t, and x3 is equal to negative 3 plus 2t for some t, right? Remember that as long as there's one value of t for which this works, then the point is on the line. So what are we going to do? We're going to substitute this inside the equation of the plane, right? So the idea, so let's actually, x is in P and in L if, so first of all, we're writing the equation of the plane, but now we will replace our components, what we have here, that I will actually color code in blue at this point. So x1 plus 2, x2, well, actually, no, I'll keep the color code as it is, I think, is equal to 3. Okay, so x1 being 1 plus t. I know you cannot see the color very well, but this one is much better, negative 5 plus 2t. And then x3 will be equal to negative 3 plus 2t. Okay? Now, from there, the only thing you need to do is to solve this equation for t. So let's go. Now I will do this in green. We have, let's add up the constants. We have 1 minus 10, negative 9, plus 3. So that's going to be 12. T plus 4t, 5t, minus 2t, 3t, so 12 plus 3t, oh boy, is equal to 3, okay? Obviously, solving this equation, you send the 12 on the other side, you get negative 9, so t is equal to negative 3. Okay, now this is not a point, right? This is the value of t that we have to give for the point on the line in order for it to also be on the plane. So the only thing we have left to do is then to say that x will be in the plane and in the line if now let's take this on the line. So x1, x2, x3 is equal to, and now we have 1 plus t, negative 5 plus 2t, and negative 3 plus 3t. Okay, and now we have to replace exactly this value of t. This is the one that will guarantee that we are both on the line and on the plane. Now, of course, you grind coffee and you get the point negative 2, negative 11, and here negative 12. Which means that the point of intersection, so the point of intersection. Now keep in mind that this is a position vector on the line, but this is also a point like in R3. So it will be negative 2, negative 11, negative 12. And this is what we wanted. I hope this was helpful. See you either in class or in the next video.